All right, so we are talking about parts of similar triangles. Again, we're still dealing with proportions, okay, but there's a lot of different pieces here that you're going to have to pay close attention to the markings. Okay, a lot of them you do the same stuff, but you have to pay attention to what you're given and where to go from there. So we're going to start. If two triangles are similar, the lengths of their corresponding altitudes. Okay, first of all, we got to know what an altitude is. An altitude, think about an altitude of a plane. That means how what?
High.
How high it is. And when you measure an altitude or you measure how high you are, do you lean sideways or do you stand straight up?
I mean, you sometimes be tipsy, maybe, you feel me?
Okay, altitude is going to be from the vertex and it is going to be perpendicular to the opposite side. That's how the altitude is. It's always perpendicular. So if two triangles are similar, the lengths of their corresponding altitudes are proportional to the lengths of the corresponding sides. Okay. What we need to do is look at our picture. We're going to look at our pictures and we have to first determine what two segments are my altitude. So look in my bigger triangle. Which segment is my altitude? Y what? YW. Okay, so that little yellow highlighted one is YW. That is my altitude. So, hold on. Let me say this first. If triangle X, wrote the wrong thing. If triangle XYZ, I forgot that part, is similar to triangle RST. Okay, if the two triangles are similar, XYZ and RST, then this proportion is going to happen. And I'm going to write it below the blank so I can write it big enough, okay? Then YW, that's the length of the first altitude. What is the altitude in the other triangle? SQ. Okay, so YW is going to be over SQ. And then that would be equal to the ratio of any pair of corresponding sides. It really doesn't matter which one. I'm going to use the side that is on the left. What is the name of the segment on the left of this triangle on the left side? XY, yep. Okay, so XY would go at the top. And then what side is in the same place but in the smaller triangle? SR. Again, it doesn't matter which side you use. It's going to be one altitude over the other is equal to corresponding side over the other. Just make sure you're using the segments from the same triangle in the same place. If you use the left triangle on the top, use the right triangle on the bottom. That has to be the same case for the second one.
I can usually do Y, W, and then CY, but you would have to do the same thing.
Right. Okay. Now the next one says if two triangles are similar, the lengths of the corresponding angle bisectors, those are segments that cut an angle in half, are proportional to the lengths of the corresponding sides. If two triangles are similar, then the lengths of the angle bisectors are proportional to the lengths of the corresponding sides. So if I'm given these two triangles are congruent, so let's see triangle TUV is similar to triangle DEF. What would be the name of the angle bisector in the left-sided triangle? UQ. Okay, so UQ is going to go over, what is the angle bisector in the other triangle? EW. And again, it's going to be the ratio for the second one is going to be any pair of corresponding sides. I can use TU or I can use UV. It just depends on what I'm given. I'm going to say TU here. No, because that side is split by that angle. You either want to use the TU or the UV. the one on either side of that angle bisector, but not the one that has like cut into two parts, if that makes sense. And what's in the same place as TU, but in the other triangle? DE. Okay. Again, I can use either TU or UV, and then I can use DE or EF, just depending on what information they give me. Sometimes they don't give me all of it. Sometimes they give me everything, and I can choose. Everybody okay so far? All right. This next one says most of the same stuff if two triangles are similar. Then the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. All right, so let's name our triangles. I'm going to go the one on the left. I'm going to call it triangle PRQ. If that one is similar to triangle FHG, what is the name of the median in the first triangle? SR, okay. What's the name of the median in the second triangle? Okay, so SR over JH. Pick a side. What side do you want to use? PR or RQ? PR, okay. And then PR would be over what's in the same place? FH. Okay, I got one more before we get to examples. Everybody ready? It's a lot. So we got altitudes are proportional to the sides, angle bisectors are proportional to the sides, medians are proportional to the sides. And did you notice in all of those there were how many triangles in our pictures? 2, okay. Then we're going to get to where we're just given one triangle. And in this one, Mariah, this is kind of going to lead you to what you were trying to do last time, okay? So an angle bisector in a triangle separates the opposite side this way into two segments that are proportional to the lengths of the other two sides. Okay, so again, it says an angle bisector in a triangle separates the opposite side, the opposite from the angle that's been bisected, into two segments that are proportional to the lengths of the two sides. So again, this is only going to happen if you have one triangle. What's the angle bisector in that picture? AP. So if segment AP is an angle bisector of ABC, then what it's going to do is the side that has been cut into two, I have two pieces. What would the name of those two pieces be? I just highlighted them. Okay, so we're going to go CP over BP. Okay, those two pieces are going to be proportional to the corresponding sides. Now, let me ask you this. I'm going to wait and let everybody catch up. What side of my triangle touches PC? AC. So AC would have to come first where CP is. And then what side touches BP? AB. Okay. If I were to have put BP first, if I were to put BP over PC, then I would have to do AB over AC, okay? Just depends on which piece you start with, then you do the same side. Okay, so again, a couple of different things. If we have two triangles, you're looking for altitudes, medians, or angle bisectors, and they are proportional to corresponding sides. If you have one triangle, that angle bisector splits what side into two parts. Those two parts are going to be proportional to the sides. Is everybody okay with that? Sure, okay.
Yeah, Ms. Bridges?
All right, I'm going to pass out your calculator so you can start setting up your proportions. It tells me to solve for what here? X, okay? So what I need you to do first is find the X in your picture. Can I find X in your picture? Okay. So I have two triangles here, right? So we're going to have to use both. What I want you to do is to start writing our proportions. What's in the same place as X but in the other triangle? What number?
There's no number.
Well, kind of is. You want to calculate it?
Oh,
Yeah. So we're going to write a proportion X over 12. And then go back to the triangle that has X in it. What is the other length that you're given in that triangle that has an X in it? 18. So 18 is going to go on top. And what is 18 going to go on top of? 27. So, again, we did X over 12. And how do I know it's 12? Because do you see those two little markings there? That means both pieces are 12. So even though it's not in the same place as X, it still is. So we're going to go X over 12 equals, then I'm going to come back to the triangle with X. The only other side length I know is 18. So that goes at the top with X. And then in the same place in the other triangle is 27. What should you do? Now, cross, multiply, and solve. Hopefully you've been working on your extra credit and you've got plenty of practice with your proportions. Cross, multiply, and solve them. I'm going to do X times 27. And then I'm going to do 18 times 12, which is 216. And then we divide both sides by 27, and you're telling me X equals 8? Okay. Make sense? Okay. Flip it over. Look at that first example at the top. I want you to find X first. Okay. Find X for me. Set up your proportion. Oh, there is no X in your picture, is there? All right, what's the first segment? Put BX. Does everybody see BX?
Can you flip the screen on TV?
Can I flip the screen?
Okay.
Oh, yeah. Does everybody see BX?
Yeah.
Label that as X. Okay, I'm going to label BX as X first. I want you to set up your proportion and solve that for X. Got to be careful here because these pictures are kind of flipped around a little bit. What is x in the same place as in the other triangle? 4. Okay, so we're going to go x over 4. In the triangle with x, we have two sides that we know. We know 16 and we know 12.5, right? What I have to figure out, though, because in this other triangle, I don't know one of my sides. I only know this one. So what side is in the same place as this, but in the other triangle? 16. How did you know that?
Square, right?
Because the square and the little double thing, right? So it's the side that's with the square and the double thing. So yes, we're going to go 16 over 6.4. I have to put 16 on top because I put x on top. X and 16 are in the same picture. We're going to cross multiply. Did everybody get 10 there? Okay. So bx is 10. That's the first thing they asked me for. What I want you to do now is go back and put 10 where you just had x in your picture. This time, what is the other segment they want me to find? QR. So let's call QR y. We're going to have to set up another proportion. What is y in the same place as in the other triangle? 12.5. Yep. Remember, we have to pay attention to where it is. Look at this. Y is on the side that has the 1 marking on your angle, so you need to go to the side that has the 1 marking on that one. Does that make sense?
Yeah.
Okay. And then you have to do it over the altitudes. Look at the triangle where the y is. What is the length of that altitude?
8x.
4. Okay. And then what did we find the length of the altitude in the other triangle to be? 10. Okay, solve that one. So I get 10y equals 50, so y is going to be 5. All right, so QR is 5. Okay, so you just have to look at what they're asking you for. If it's not already labeled with a variable, label it. All right, I know your picture is probably not as easy to see as mine is, so if you want to look at mine because it's in color. It says a police officer is determining where to park his vehicle to observe traffic at the red light. If AC equals 512, that's what that should say, 512. Does everybody see AC? Here, let me draw it to the side. This is kind of what our picture looks like. A, Y, C, B, Q, P, R, Z. So it tells me that AC is 512. And then it says that RP is 384. Whoops. Where is this? And then it says Y is 201 feet from B. So the distance between Y and B, does everybody see Y and B? Yes? Okay. I'm going to put 201 there. It wants to know how far it is from Q to Z. So what do I call that if I don't know it? x. Okay. Well, Mariah, this does work out to be like what you said. Set up your proportion. One altitude over the other equals a side from that same triangle over a side from the other triangle. If you start with x, you got to start in that same triangle in the other proportion or in the other ratio. Tell me what my proportion should look like. X over 201, okay, is going to equal 384. Yep, that's the side in the same triangle with x over, there you go. Well, this is going to be a big number. I got a decimal too. Let's see, 512x equals, what is that, 77,184? And then divide that by 512. What do we get, 150.75?
You did that in your head, Miss Bridges? No. What I said.
No, I'm not smart like that. Does that make a little bit of sense?
Yeah, Miss Bridges, for sure.
Okay. All right, let's take a look at the next one. I'm going to help you set it up, and then I'm going to let you finish it. That's the last one, right? Okay, so how many triangles do I have here?
2.
Two. Well, technically, yes, but if I'm just looking at the big picture,
1.
just one. All right. So that one says that my two pieces, this little piece JH over JG, is going to be proportional to the sides that are crossing them, right? Okay. However, what does X represent, though? Does X represent one of my pieces? No, it represents that whole side, right? So if the whole thing from G to H is X, and from G to J is 12, how would I represent that JH? X minus 12, okay? Remember the whole piece minus? Now set up your proportion. Okay, follow the color codes. The little piece that's yellow goes over the little piece that's blue. And that's going to equal the big piece that's yellow over the big piece that's blue. Over. Yeah. Is it who? Mm-mm. Mm-mm. All right, X minus 12, what is that going to go over? Okay. And that's going to equal, there you go. Does everybody understand where that came from? One piece of the side that's been cut apart over the other piece equals the corresponding sides in a proportion. We are going to cross multiply. But here's the thing that some of you may have made a mistake on. When I multiply 30, I'm multiplying it by the entire X minus 12. And then I've got to multiply 12 times 25. Think about 12 quarters would be $3, so 300. Yeah?
Mm-hmm.
What do I do with that 30?
You did that in your head?
I did.
Okay.
What about 30? What do I do with it?
Distribute it.
Yep.
No way, Miss Bridges. You did it in your head too?
Multiply 12 times 3 and stick a 0 on it, yeah. Add my 360 over. So 30x is going to equal 660. and we're going to divide by 30. And so what did we get for x there?
2 in your head, Bridget. No. Let me double check.
Anybody have any questions? All about setting your proportions up properly, and then you just cross multiply and solve.
You did in your head, Bridget?
I did, but I also have the answer set right here in front of me. But yes, I just did 66 divided by 3 because you take a 0 off of both of them. You don't have to worry about the 100.
No.
Okay?